Hello and welcome everybody to our webinar today, Automating Kubernetes with EKS and GitOps, presented by Weaveworks and AWS. A few housekeeping items up front. Please note that this call is being recorded, and at time all participants are in listen-only mode. We do encourage questions, so please, if you'd like to ask questions, use the Q&A panel and we'll address those at the end of the presentations. It is my pleasure to hand you over to our speakers today. Michael.
Hey there, everyone. My name is Michael Hausenblas. I'm a developer advocate in the AWS Container Service team, looking after container security and EKS, and working together with the Weaveworks folks to, make eksctl and GitOps reality.
Hey, thanks, Michael. I'm Kalbir Sohi. I'm a product manager at Weaveworks, focusing on EKS Control since I joined, and looking at how we can make it a great tool for using EKS and other AWS services. So I guess without further ado, I will take over. I'm going to be doing most of the talking today. So here's a sort of overview of what we'll be talking about. So we'll give an overview, intro to Weaveworks and what we're about, what we do. Then we'll spend a bit of time talking about EKS and EKS Control, give you a bit of a lay of the land of what is going on with those, with the service and our project. Then we'll spend a bit of time talking about GitOps and what it is, how we sort of came to sort of think about it, and some of the key sort of aspects of how it's used. Then we'll talk about GitOps on EKS with EKS Control, and that's where we'll show hopefully a very, very smooth demo of some functionality we've added to EKS Control to make it easier to do GitOps type stuff and configure and manage Kubernetes clusters with GitOps. And then finally, we'll talk about where you take things from there. So once you've got things set up, where do you go? So let's start with talking about Weaveworks. So I think lots of people have heard about Weaveworks and our work through our contributions to Kubernetes and the CNCF. So we are large contributors to many open source projects focused around making Kubernetes and making infrastructure easier to manage and maintain. And some of the key projects that we've worked on and created and sponsored include things like EKS Control, things like kubeadm for setting up Kubernetes and clusters, WeaveNet, one of our first products, which was for networking on Kubernetes, and then some of the things we've been involved more recently, Flux, which we'll be talking about a little bit today, our GitOps operator, which is now a CNCF project. We've handed over to CNCF to the community to sort of drive forward development on Flux, and a bunch of other projects there, including upstream contributions to Kubernetes. And all of that has made us one of the top 10 contributors to CNCF projects, which is kind of punching above our weight, really, because we're quite a small company, but we invest a lot in this space, and we've done a lot of work in making sure that we're building and pushing forward tools in the way that we think is best, the way that we learn from our engagements with our customers. But we also do commercial projects. We also work, for money, like many other companies, and those split across, broadly speaking, two types of things. We help a lot of people to get unblocked with their Kubernetes work, and we help a lot of people who are stuck with more complex deployments, and certainly with getting their teams up to speed and using Kubernetes and rolling it out into complex environments and settings. And so that is consulting work, training, CRE services that we provide to people to help them accelerate their deployment of Kubernetes and cloud native technologies. And alongside that, we offer products particularly our Weve Kubernetes platform, which are a faster way of getting deployed and set up with Kubernetes and getting that into production. Now, I'm not going to be talking about that at length. We're talking more about the open source side of things today, but it's worth touching on that we do help people in a wide range of scenarios, and we do have products that look at some of the more complex cases that people need to deal with, whether that's looking at multiple teams using clusters and how you do isolation and how you do multi-tenancy and things like that, where you're looking at audit, compliance and monitoring, and really the things that you need to do to run Kubernetes in a sort of quite challenging production environment. So that's Weaveworks. Let's talk a bit about EKS. So just to begin with, I'm going to give just a very quick overview of some interesting bits of Kubernetes that will be worth knowing about if we're to sort of pick up on the rest of the stuff. So Kubernetes at a high level is really a way of controlling a bunch of machines, a bunch of computers, nodes that we might call them, and deploying workloads onto those nodes. So you have applications, you want to run stuff on infrastructure, and the aim of Kubernetes is to make that easier. And so what we have in our world is a bunch of computers that we want to run applications on, and each of those applications is run in an entity called a pod, which is a collection of containerized workloads or applications hanging together. And we'll run them on computers, and Kubernetes will sort out for us how they get resources and things like that. How does it do that? Well, the other half of the Kubernetes setup is the control plane. So whilst we have nodes and what we might call the data plane where we run our applications, we then have a central control plane that will that we can tell how we want to run those applications and what we want to do with them and where to run them. And we leave it up to the control plane to manage a bunch of the complexity around that, and in particular to schedule those applications, put them on the right machines, give them the right amount of memory, etc., that they need, and to make sure that they're running when we want them to run. The way we do this is by providing that control plane with some declarative configuration. So we'll provide Kubernetes with a description of how we want the system to be in configuration, and then we'll let the control plane do its business to make that configuration true, to make the thing that we have declared occur in the world. So we declare the state of the system that we want to see. Where do we want our, what workloads do we want to be running? How do we want to run those things? How many of them do we want to run? How do we want to route to them, etc. And Kubernetes will sort that out. The way we do that is by giving applying configuration to the Kubernetes API. The API runs on the control plane, and the control plane also takes care of holding that state. And every time we want to update it, we give it some more configuration, and it will update that configuration in the control plane in the database, and then it will apply it out into the particular nodes and make sure that they're running in the way that we want them, that we've declared them to run. So that's kind of how Kubernetes works, overall at a high level. When we start thinking about EKS, we are sort of thinking about different ways that we might run Kubernetes. So many of the people who've been running Kubernetes, say over the last 2 or 3 years, may have provisioned and managed all of those pieces themselves. So the primary way I think that most people had of coming to Kubernetes initially was to set up a control plane, set up nodes, set up a data plane, configure those things so that they would work together, and then have to manage the whole of that system, and in particular manage some of the sort of more complex sort of parts of the system in the control plane, particularly the database, and making sure that that is available and resilient, right? So you don't want that brain of your system that's holding the state and telling the whole system how it should operate. You don't want that to disappear. You don't want it to have a downtime or an outage. You don't want to lose any of the data in that control plane. So there's a significant amount of operational work that goes into keeping that control plane up and running, so that your nodes know what they should be doing at any given time, and your workloads know where they should be running and how. The EKS does is takes away the management of that control plane. So the AWS Kubernetes service is a managed service, and the thing that AWS manages the control plane. And so what they're doing there is guaranteeing that aspects of that, aspects of that control plane that you care about, that it's available, that it's reliable, that it has enough capacity to do the things you're asking of it. Those things are all there. So we're talking about backup, scaling, the control plane, making sure it's available. AWS is taking care of that. That's AWS's problem. So when you create a cluster, what you'll get is a control plane that's taken care of. You, the user, have to take care of the data plane, those worker nodes that we saw. So where you want to add capacity, you want to provision capacity, you need to update those things, you need to scale them. That's in your territory. As I said, EKS is focused on reliability and security. So the reason that AWS are managing that control plane, and the reason that they're good at it, is because they're good at making that thing reliable, and also making decisions about that control plane that make it secure. Another value of using EKS is that it integrates closely with other AWS services. So for instance, IAM roles, applying IAM roles to your cluster and giving, say, workloads particular services or particular nodes IAM roles, so that they can do things on AWS, or you can do things from those workloads on AWS, and therefore integrate the application that you're deploying to Kubernetes with other things on AWS. That's a very tightly integrated function of EKS. And there's other ones, cluster logging into AWS's logging service, CloudWatch, again, very well integrated. So you can see what's going on in your cluster and sort of understand and sort of get logs and information out of that without having to, say, run another logging service. So those are the main sort of features of EKS, the main things that AWS are aiming for with it. Now, I think I'll hand over to Michael for a moment.
Right. So now that you have a basic idea of what EKS offers, you might wonder, how do we determine what to add next? And one really important way to understand what you want is our public roadmap. And I believe we're the first service team that had a public roadmap up on GitHub, and others seem to start copying that idea. And that's great. And this is really, I would say, one of the best ways to clearly say, hey, this feature is missing, coming up with a new feature, reporting what kind of things you want. And this is what we in the service team very closely monitor, follow up, and trying to get as much done as possible. More than 80% of the roadmap is actually determined by user input, and this is the best way in case of EKS for you to flag what you want to see. And if you're not that familiar with EKS, there is a nice EKS workshop, eksworkshop.com, where you can start from scratch and use eksctl as well to provision EKS clusters and work your way through everything from networking through RBAC and storage, Helm charts, etc. Okay, I guess with that, we've pretty much covered the basics of EKS.
Cool, that's great. So let's move on talking about EKS Control. And you'll probably notice that I sort of interchangeably use EKS Control, eksctl, but I might even drop in an EKS CTL I am one of those people who hasn't quite decided which pronunciation I'm going to use, so I tend to vary. So EKS Control is a tool written by Weaveworks. So it's an open source tool, and it's a CLI for managing EKS clusters. Now, the first question that you might have if you sort of coming to EKS Control new is why have Weaveworks produced a tool for managing EKS clusters? Like, isn't that what AWS were doing in the with the EKS service? I think it's probably worth pointing out that when EKS first started, as I kind of indicated before, whilst AWS are taking control of the taking care of managing the control plane, they weren't at that stage giving users very many options as to how to do the data plane and the nodes there. Basically, you were on your own with the data nodes. And so we've worked for a bit of a gap here, because when we started trying out using EKS, we sort of found that there was quite a lot of work to be done to get the data plane nodes into a sort of fashion that we were happy with, right? So we wanted to set up a bunch of resources around those. We wanted to set up security groups. We wanted to set up IAM policies. We wanted to create those nodes and those EC2 instances in auto scaling groups and name, give them the right sorts of sizes and things like that. And we found that quite an arduous experience to kind of set that up in the first instance. So one of our engineers here, Ilya, he was really kind of focused on the idea of, could we make something that made it as easy as saying, give me a cluster on EKS, and that would not only give you the control plane, but would also give you a data plane that you'd specify. So give you some nodes and now give you the entire cluster that you wanted to work with. And so he sort of started working with this with the CLI tool, put it out there, and I think it's fair to say it's got a lot of interest, and a lot of people sort of agreed with his intuition that we needed something to kind of get us a few steps further forward with the creation of a cluster. So that's how we came to build EKS Control. Some of the things that we're kind of very keen on maintaining it, and some of the things that have been around in its design, is that it's developer or operator friendly. So we're trying to make it, that was one of the sort of design principles, we're trying to make it so that it's very easy to do certain tasks. It's very easy to get you into a position where you can get the resources and things that you need out of Amazon, out of AWS, and get them hooked up on EKS, and that it's cluster centric. So we're trying to sort of abstract away from all of the various pieces you need to build, say, the nodes or the data plane that you need to build to get your workloads running, and sort of say, hey, can I just have a cluster, and then having some reasonable defaults in there, and letting people then iterate on that and make those changes and sort of go underneath and make more complex decisions once they've had a go at actually getting the first thing provisioned. And so that's EKS Control's really popular tool. That's what I've been working on since I've been at Weaveworks, and we're seeing a lot of adoption, a lot of increased interest, in part because of this. So in July of this year, AWS announced that EKS Control is going to be the official command line for EKS. And this is something that us at Weaveworks and AWS have been working on together to make sure that we sort of harness the sort of good design principles and good work that we've done around the open source project, and kind of bring that into enhancing the user experience of the AWS service overall. So this was a really great moment for us. It meant we could sort of get a lot closer with AWS, and so as a result of this, now what we aim to do is release features in tandem. So as Michael showed you, there is a public roadmap from EKS, and our aim at Weaveworks is to make sure that EKS Control supports those features as they're released on day one, wherever possible. And we're still looking at that developer-centric view. So we'll look at a feature that AWS are introducing to EKS, and we'll really think about how do we make it sort of quite easy, quite slick? How do we make a good user experience around adding that thing with EKS Control? So we're releasing features in tandem. We're included in the documentation, as Michael pointed out earlier. You know, if you look at the EKS docs, you'll see EKS controls in there. And we work together very closely. The EKS team and our team and Weaveworks and other people in AWS are working together to kind of make sure that we have a joint direction and kind of understand the priorities that we want to work on jointly. So what can you do with EKS Control? Well, we've talked a little bit about simplifying cluster creation. So as you create a cluster, as you create those nodes that you need to run applications on and want to deploy those applications, we've tried to make it simpler to put all the pieces together to run those, run that data plane, run those nodes. But we've gone a bit further than that. We've got some nice things in there that we think are really beneficial. So one of the concepts that we were quite keen to put in at the beginning was having auto-scaling node groups. So as we talked about, when you provision a control plane, a managed control plane for EKS, you then have to add your nodes to it. And so we have the concept of in EKS Control of having a node group, like a set of nodes that sort of work together, that you can sort of provision together, and that you can set an auto-scaling group around. So you can sort of say, hey, I want these to vary between, say, 1 and 5 nodes based on, you know, based on resource utilization. And that's been quite a useful and interesting feature. So we're taking it a bit further than just having the most basic thing that we can offer in a node group, and we're trying to give people features that are useful to them. So we talked about cluster-centric abstraction. Some other things you can do are using spot instances for your node group as well, trying to reduce the build there that people are racking up for their EC2 instances, and integrating with other AWS services. So we tried to make it sort of native, that you can add certain IAM roles that we know will be important for you to add to your clusters. And more recently, AWS have released features around giving specific pods access to certain IAM roles, so that you can do things from a particular application or a particular pod. And we've made that, and working with Michael, indeed, we've made that a good user experience in the CLI at the same time. So in practice, what does that look like? Here's an example of how you can create a cluster. So in EKS Control, we have command line options to create clusters, but we also allow you to create clusters, or enable you to create clusters through a file. And so creating a cluster here with in a particular region with a single node group of M5 largest, quite commonly used instances, with some IAM policies, you can see that it's what we're trying to do is make it quite a simple, straightforward experience to do that. And where possible, we're trying to use and copy and get design inspiration from like idioms used more widely in Kubernetes, like the -f, the application of a file, to apply this kind of config and create clusters from it. And then we can sort of see how we might do sort of more complex things. So in this kind of example, we're extending that initial sort of idea of a small cluster with a couple of nodes to a cluster with 2 node groups that use labels so that we can attach workloads to specific node groups, to specific nodes, and thereby segregate, say, management functions from application workloads. And so again, you can kind of see that we're trying to give quite a lot of power to users to create clusters in a way that is useful to them, but do that in a simple way, and have sort of configuration and functions that get you quite far with defining what a cluster should look like to you. And in terms of our roadmap, so we'll be talking about GitOps and cluster profiles a little bit later. That's one of the cool things we've been doing on our roadmap, and sort of say about the motivation there. We have some other things that we'd like to do in EKS Control, including the idea of EKS Control Apply, where you can sort of take a cluster and sort of update it by giving it a declarative config and updating all of those things on the cluster. And then we'd like to look at things like migration support. So how do we help users migrate from other platforms to EKS, something that we talk to people quite a lot about. And we're also following upstream work in things like the SIG cluster lifecycle work, where there's a talk and trying to get an understanding of how are we going to manage the lifecycle of applications that run on Kubernetes that we need all of the time to be there. So things like core DNS and things that are going to always be running on our clusters. And as we upgrade our clusters, we want these components to upgrade. We're working with the wider community to try and come up with solutions to manage that stuff. All of that is kind of EKS control direction that's kind of in addition to adding the features that we need to add for as EKS is adding features. So that's sort of bonus on top of keeping in step as the official CLI. So now that we've talked about EKS and EKS control a bit, let's talk about GitOps. So I think every presentation by someone from Weaveworks about GitOps has a tweet from Kelsey Hightower, influential Kubernetes personality who's quite sort of opinionated about GitOps, thinks it's a great thing. And this is quite a bold statement that he's making out there, the best thing since configuration of code. So what I'm going to try and do is motivate, this statement, sort of give an explanation of why Kelsey might believe that this is the case, and why we at Weaveworks really think that GitOps is kind of moving forwards. It gives us the ability to move forwards how we manage the configuration of our infrastructure. So to start off with, what is GitOps? It's a standardized workflow for how to deploy, configure, and manage Kubernetes. And I'll walk through, some of these pieces. But the core idea is that we will link, given that we can define what we want to run, we can declare what we want to run on Kubernetes in configuration files. We can describe the total state of how we want Kubernetes to be in configurations files. Can we use tooling that we're very familiar with as developers, in particular Git-based tooling, to hold those configuration files as if they're code, and then keep in sync our Kubernetes clusters with that configuration that's stored in a Git repo. So the situation we want to get to is we have a Git repo that describes the entire state of our Kubernetes cluster, and we know at all times that the Kubernetes cluster matches that state. So to break that down a bit, the entire system is described declaratively. So that's where we're saying we have all of these configuration files that tell us what state we want the system to be in, to declare the state that we want it to be in. That canonical system state is versioned in Git, so we can see how it changes. We can see when people make changes to it, who made changes to it, why they made changes. One of the great things about Git is that we can add context to those changes and sort of say why things are moving and changing. We can see that changes that we approve in that Git repository are automatically applied to the system. So as soon as we update our Git config of how we want the system to be, it gets rolled out to the system itself. And so we're trying to keep those things in sync. And then we run agents that tell us if anything gets out of sync. So if something changes on that cluster and now the configuration that we've declared and we've version controlled is not the same as the stuff that's running on the cluster, then we have a problem and we find out about that. So this is moving away a bit from the way that many of us maybe started with Kubernetes. Certainly I started with Kubernetes, the way that many guides and tutorials kind of start us off with running workloads and things like that, which is to use kubectl, great tool, to apply manifests to Kubernetes directly, to apply files, and then through the application of those files to see those running things. And that's how many guides kind of go. That's how many things sort of get you started. And I think in saying that we want to move away from this, what we're saying is that we want to get greater control and greater sort of visibility over the system that we're running. And I don't know about you, but whenever I have sort of started doing some experiments and sort of working with Kubernetes from the command line, I tend to get into a situation where I can't really remember what I'm running anymore. You know, I've applied a bunch of files and made some changes because some stuff didn't work, and then you know, I applied some more files and it's all kind of in place. I haven't really been keeping very good track of that. And I guess what we've been thinking and what we sort of believe in Weaveworks is we have the tools around us with Git to, you know, keep track of that, to actually keep that state and keep it understood and keep it in sync with what, you know, where we want it to be, so we can move away from the ad hoc way of applying changes and move to a more structured way. What does that structured way look like? Well, the core idea is we have a Git repository. In that Git repository, we are putting the configuration for our cluster, the things that we want to be running on our cluster and how we want our cluster to look. And then we are using tooling to sync that Git repository with the cluster to make sure that the cluster is running, matches the things that we have in that Git repository. And the tooling that we have developed and we use at Weaveworks, the main tool is called Flux. The Flux is sometimes known as the GitOps operator. And what Flux is essentially doing is watching your Git repository, and as you add things and make changes in there, applying those to your cluster, and then watching your cluster to see whether anything is changing there. And bringing it back into line with the Git repository at all times. So the kind of situation we'll be in is we have say a cluster operator who is thinking about adding a workload, thinking about making a change to what's running on their Kubernetes cluster, and rather than applying it with kubectl, instead they would take that config. Maybe they've worked it out, maybe they've experimented with it in a more manual fashion, but once they have the config that they want to run, committing it to Git and making that change in the entire system declaration. One of the key things, I guess, that that's sort of in this picture is what we'll be declaring in our config is the stuff we want to be running. We'll then be pulling that in to the cluster from something like an image repo. So in our configuration, we'll be stating the way we want the system to be, but actually getting it into that state is the job of Flux. And Flux will be pulling that from various sources, from various image repos to make sure that it can get all of those things running. So why do we care? Why do we think that this is a good thing? Well, lots of the properties of Git we can sort of leverage to get you know, better functions of how we manage Kubernetes. So for instance, trivializing rollback. Now a rollback is going to a prior Git commit of my repo, right? So if I want to, if I'm in the middle of an instant and it's you know, the middle of the night, and I know that the system was working at 6 p.m., I can roll back to the state that it was at 6 p.m. I can go back to that commit, and then that's the one that I know that will work, and I can get Flux to bring the system back into the state that it was in at a known good point. We get great auditing and attribution, and I guess as I said before, we get history, we get that context, we get separation concerns and security boundaries. I'll be talking a little about that in a second, but we get to like leverage the functions of Git. So lots of our team members, lots of our developers that we work with can use and understand and are comfortable with Git and know how that works. So making changes and adding things into there sort of can replicate the workflows that we use there. So if we have an approvals workflow for how we're adding code into Git, we can use the same sort of thing for configuration. Just to sort of touch on that's what we've been talking about is the cluster configuration. How does this work if you're in a development team sort of writing your apps, right? Is it the same repo? Is it a different repo? How do we get that app sort of pulled into Kubernetes? Well, the way this works in a GitOps world is the app team will continue to write their application in their Git repo, will build it, and the end state of what they are building is an image. And so their pipeline is the top one that we see here. It's the pipeline that gets you to the point of building an image. The thing that we do in the cluster configuration is name which images we want to be using. So by saying the total state of the system we want it to be in, that will include, oh, I want version 1.5 of this image in running on this cluster. And so it's not that a change in your application code will initiate a change in your cluster necessarily. You can still have that control between the two elements and sort of decide when you're deploying. The way you do that is by building images, and then in the Git repo for your cluster config, naming which versions you want to have in which places. And so that's kind of like the separation between continuous integration, continuous deployment. The end state of the first one is an image. The end state of the second one is the total state of the system of Kubernetes that you want to be, including what should be running where and which versions. And you can kind of see that you can have a similar sort of system where from a single repo you could describe which version you'd want to be running in say a staging environment, and describe a different version that you'd be wanting to run in a production environment, and utilize your existing sort of approvals workflows to make that work. So what should be GitOps here at Weaveworks? We think pretty much everything can be GitOps, and we have a lot of projects out there, and you can see under our GitHub repo that we kind of try and apply this kind of principle to anything. So for example, we build dashboards for Grafana. We have a project Grafana lib, and we can build dashboards for Grafana in code, and we ship those to our clusters. So when we build a new cluster, we know that it will have certain dashboards defined, because we've got those in the same repo, and our aim is for GitOps to take over the whole world and for us to be able to describe everything in code. And so a step on our way is bringing GitOps to EKS and EKS Control. So I think it's kind of clear we love GitOps here at Weaveworks. And one of the things when we think about the direction in which to take EKS Control is the thought of adding GitOps to EKS Control. How are we going to do that? We'd like to do that and make that work. So we have added in a feature to EKS Control, currently named EKS Control Enable Profile. It's the command. And what it does is, when you have a new cluster on EKS that you've provisioned, we want to set up that cluster for GitOps, and we want to prime it with a bunch of things, a bunch of applications that we think are good to run on any cluster that will get you sort of further with where you want to be with writing your applications and code. So what we've done is built what we call a profile, and a profile is a bunch of applications, and we'll see this in a moment. And we've made it very easy for you to, in one command, deploy Flux, our GitOps operator, onto your Kubernetes cluster, link that up with a repository, and then put into that repository a bunch of configurations for things that you'd want to run on a Kubernetes cluster. So things like Prometheus for monitoring, things like Grafana, things like defining an ingress using Amazon's ALB. And so what I'll do here is just walk through the process that we have for doing that. And what I just want to do before I do that is note that the thing I'm about to show is experimental, and it's changing. And you'll see when we run the commands that we have a way of running experimental commands on EKS Control. So it's out in the world, and you can use it right now by running the experimental command. And we're taking feedback on how this works, and we're getting quite a lot of good user feedback right now, and we're making changes in response to that. So some of this is going to change some of the detail. Okay, so let's move to the demo portion. So let me see if I can do a new share. Here we go. Right, so can you see my screen there? Someone confirm, Michael?
Yep, I can see it.
Great. So I will just start off by showing you that I have a couple of clusters. So I'm just going to use the EKS Control command to just see that I've got a couple of clusters. In fact, I've made two because things always go wrong, and you don't want to be left with just that one. And what I'm going to do is run on the webinar cluster one. I'm going to run the profile command, and we'll set up that cluster with a bunch of workloads and with GitOps. But just to start off, what I want to do is show that we don't have a huge amount of stuff running on this cluster to begin with. So a new cluster, a new EKS cluster, you get a few workloads that you really need to run EKS, but you don't get much else. It's up to you to then add things and decide what you want to do with them. So just looking at, sorry, I'm looking at webinar cluster 01 here, and I don't have very much running on it. So what we're trying to do, what our aim was with the enable profile command was to get you to a point where you got a lot more running on it, and get you to a point where you're a bit further along with this thing. So to run the command, what I need is a empty Git repository, because when the command runs, it's going to put the workloads that I want to run on my cluster. It's going to put the definition and the configs of those workloads into this repository. So I'm going to create a new repository here. There we go. It's on GitHub, and I'm just going to take. Actually, I'm not going to take that. Now I'm going to run the command, which I have hopefully got here in front of me, and I'll explain what's going on. So as I said previously, it's an experimental command, so we are, on the cutting edge here. And what the command is going to do here is apply a profile that we're calling appdev to my cluster. And I've given that. I'm just going to scroll up here for a second. I've given the command the Git repository that I want it to store the generated configuration in. I've given it my Git email so that it can commit with my email address. I've told it which cluster I want it to operate, and I've told it which region that cluster is in. And then what the command starts by doing is it starts by getting Flux set up. So Flux is the thing. Okay, now I was not expecting this to happen. This is the classic issue of demos. So I'm going to try that again, but I'm going to try it on the other cluster, just in case I'm in an odd state. So I think this hopefully work. So just to return to what I was saying, and hopefully this time it will work. The first thing that the command does is it deploys Flux to your cluster. And what it timed out doing here was we install a version of Flux that includes a Helm operator, because we know a lot of people want to deploy workloads to their cluster using Helm. And one of the projects that we've worked on here at Weaveworks, and we've donated now to the CNCF, is the Helm operator, which allows you to put a configuration file called a Helm release into your cluster config, and to then pull down a Helm chart based on that. So I'm going to give this one more go by doing something slightly different, which is I'm going to create a new repository with a different name. Let's call it A3, say. I'm going to continue working on cluster O2, and I'm just going to switch this to A3. I'm going to see if this is going to solve my problem. So I've been a little bit unlucky here. Right, so yeah, so the first thing that the command does is deploy Flux and the Helm operator. The second thing the command does is take a bunch of configuration for workloads that I was describing earlier and puts those into the Git repository that we have given it. And then the Flux that it deployed onto your cluster will watch that repository and wait for those configuration files to appear, and then when they do appear, it will start deploying those configuration files out. So hopefully that is what we're going to see. Here. Okay, so whilst we are waiting for this to go on, I might just move back to let's continue there. I might just move back to my presentation and walk through the last few bits, and then I'm getting a message from Cyrus who's saying that Docker Hub is down, so my demo is failing because of that, which is pretty bad luck if you ask me. So if that is true and that's why it's failing, I feel a bit better than I did a minute ago when I thought it was something that I was doing. So I'm just going to move back to the slides, and we can blame Docker Hub for a moment or two. Maybe that's the truth. And I'll just walk through the remainder of the slides. So what I was hoping to show you essentially was that with that command, with Flux being pulled from Docker Hub and deployed onto the cluster, it would be watching the repo that I gave it, and it would be taking the configuration out there and deploying a bunch of things to your cluster. And at the end of that process, on your cluster, you have running Prometheus, you have running Grafana, you have running ALB Ingress, and some other example workloads that we think it's helpful for people to sort of understand and see how they work in a GitOps way. What's next? I guess it's probably a little bit mysterious given that we didn't see the completion of the demo, but given that the quick start gets you to a point where you can sort of make some changes in your repo and then see those changes reflected on your cluster, and sort of see if you make changes in your cluster that you'll get back to the state defined in the repo. Some of the things that we get asked about sort of immediately on from that kind of setup where you just got one cluster, one configuration managing that cluster, is how do we do things around multi-tenancy? We got multiple teams working on our cluster, and we want to make sure that they have their own space to work in, but there's a separate area where operators can manage the overall cluster configuration. And we have a project out in the world around multi-tenancy, which shows you one way that you can set up your cluster to have many teams, each of them working in their own specific namespace that's linked to their own configuration, so that they have control over the things that they want to do, but at the same time we can apply a global configuration to the cluster and can make sure that we're controlling the overall state. So that's a direction that you might want to go in next. The thing that I was hoping to show you was the app dev profile. The idea of a profile is that by applying it, by using the enable profile command, we get you a bunch of applications, a bunch of workflows that we think are useful for a particular purpose, in this case, application development. And we're working on producing more of those profiles. So we got some in progress around progressive delivery and about being able to do A/B deployments and being able to do deployments that are rolled back if you get a lot of errors from your application or you have any problems with that. And what we're doing is building into EKS Control the ability to sort of say, hey, I want this profile that gives me progressive deployments, just add it to my cluster when I create my cluster. So as soon as I'm creating my cluster, create it with that profile, and you'll have that functionality on the cluster from day one, assuming that Docker Hub is working. So we're working with AWS to sort of identify more areas that we may want to put profiles out there, more use cases that we want profiles to work for. And so that's something to keep an eye on, is we'll be putting more of those profiles out into the world. And finally, as I sort of said at the top, we have our Weve Kubernetes platform for more complex cases, for more sort of complex configuration, for scenarios where you're working in, say, with multiple cloud vendors, or you're working with multiple, lots of teams and lots of complexity. We see people growing the number of clusters that they're running, and we see an explosion in the complexity of the configuration that people are using. And what we're doing is, in our open source work, we're building tools that help you manage that complexity yourself. And in our commercial product, we are building tools that manage that complexity in a more automated way, with maybe more of our opinions built into it, to sort of say, this is the way that we think is the best way to deal with this complexity. And the problems that you face when running, workloads in a real production setting. So that's me. That's some information, some contact information for us. If you search Weaveworks GitOps, you'll find lots of information on GitOps, lots of information on EKS Control. The thing I wanted to say that I didn't add here is we also have a Slack at Weaveworks, where we have a channel dedicated to EKS Control. It's a very vibrant channel. There's a lot of questions going on in there, and there's lots of people who will tell you that Docker Hub is down, and that's why your demo isn't working. So thank you to people who are hanging out there and passed on that message. But yeah, it's a great place, and there's a lot of people solving problems, as a thriving open source community does for each other. And we're learning a lot about the way people want to run EKS and the things that we might improve in EKS Control from the conversations that we have there, and the issues that people are raising on the EKS Control repo and GitHub. So I hope that you get a chance to try out that functionality. It's documented in our documentation. There's a guide showing you how to do the GitOps enable profile functionality, and hopefully you'll have more luck than I did today. But if you run into any problems, jump into the Slack or raise an issue on the repo, and we'll take a look at that. So I think we have a few minutes for some questions.
Yes, if you'd like to ask a question, please use your Q&A question panel on your Zoom menu. We've had a few questions come in. The first one is, can you explain why we need a Helm operator here?
Yep, good question. So I guess this is me. It's a bit of a product decision, and I guess we were looking across at the most common ways that people deploy applications to Kubernetes, and I think everyone knows that like Helm has a massive market share, and that's really how lots of people are managing their deployments. And we want to make that GitOpsable, or GitOps in some terrible mangling of the English language. And so including the operator from day one kind of meant that we were able to say to people, we think this Helm chart is good. We think it's a good way of deploying these workloads, and here's a way that you can do it using GitOps. So that's really the decision. I mean, it'd be interesting if people have feedback as to why it might be worth taking it out, or different modes. I know I've seen a few issues on the repo where people have talked a bit about the adding in the ability to use Helm on a command line a bit more, making that a bit easier, and we are looking at sort of potentially doing that. But I guess our first place was, can we GitOps Helm, and do we want that to be a default? And I think our initial answer was yes, because lots of people use it.
Great. Next question is, does EKS Control provide an easy path for worker node upgrades, i.e. AMI rollouts?
Yes, easy is a, you know, that I'll leave it up to you as to whether it's easy or not. Node groups are immutable, and we have a set of commands that will essentially take you through bringing up a new node group with the changes that you want on that new one. So let's say you have new AMIs, or you have you know, a different Kubernetes version, let's say, then draining the old node group and ensuring that the traffic is sort of served from the new one. So that's the process. It's documented. It's a few commands, and you know, you have to follow those steps. I think it's pretty straightforward. Whether or not I said somewhere in this deck, I think I said I like magic, and I feel like this is a little bit, you know, I like some of these things to be like, you know, a bit smoother. So some of my aim is to potentially make some of these things smoother, but I think there is a solid and well documented way of doing it.
Great. Are you planning similar commands for other cloud providers?
Interesting question. Not right now. You know, we're getting a lot of interest and traction, and just a lot of work from the EKS one, and we have a really good relationship, as you see, with AWS. I think that, you know, we often think about it, and sometimes it might be useful for us, Weaveworks as a company, and I think that would drive us to do it. But I don't, at the moment, we don't have really the capacity, because of we're quite a small company. We don't really have the capacity to. It takes quite a lot of work to maintain, and I think we're sort of just about keeping up with good maintenance of EKS Control. I think adding another one right now would be a bit more work than we have capacity to do. Having said that, if Microsoft or Google or anyone else came along and said, we love the work you're doing, you know, if anyone's listening, happy to have that conversation, but it's not on our plans right now.
Is there any downtime involved in above control plane upgrade?
If I understand that correctly, I think I think we're talking about upgrading the control plane, say from 115 to 116. I'm pretty sure that the answer is no, but I'm just going to go to Michael to confirm that.
Yeah, correct, because that's what we're taking care of, essentially.
Right.
Yes.
Okay. How do you upgrade? How do you integrate your EKS cluster with an RDS instance? Is there a GitOpsy way of doing this?
Yes. So I would say, I guess we're maybe in the space of opinions now, and I'll let Michael sort of come in with an opinion after me. I would say that it depends a little bit on how sort of bleeding edge you want to be. I would say right now there isn't a core native bit of EKS or EKS Control that just does that kind of thing, that, you know, gets you an RDS spun up and integrates it. So I would go to tried and tested tools like Terraform. Say if you were in a scenario where you know, needed to know that thing worked all the time and it was solid. But I know, and I'll let Michael talk a little bit more about this, I guess. There are projects, and I'm thinking about the service operator, the AWS service operator project, that will let you create resources in the same repo, say that you're creating them for the general cluster configuration, and then we'll provision those resources in AWS. And I'm very interested in it, and we at Weaveworks are like very keen to sort of move along in that way. But I don't think I'd be out of place, Michael, in saying if you were going to do that today, you'd be, you know, on the edge of this kind of work.
Yeah, correct. And as you pointed out, the AWS service operator is definitely where we are focusing the attention there, to essentially provide a unified API across, you know, both the applications that run within the Kubernetes cluster and the AWS services. And of course, in the long run, you could also think about making that part of a profile. So it's essentially, you know, part of the EKS cluster if you're using EKS to provision that. But we're talking about, timeline of beginning next year. So it's up on the container roadmap, issue 456, I believe, if you want to comment on that or have a look at that. But we're definitely super interested in working also with the wider community to make that a reality.
Great. I think we've got time for one more question. Is there any Terraform integration of sorts planned for EKS Control? For example, passing subnet created by Terraform to EKS Control cluster YAML file?
Planned, I would say no, but I and Ilya and other people at Weaveworks, we're really interested in how we can work more closely, how EKS Control and Terraform can work more closely together. And we have a few ideas, and you'll see there's a few issues on the repos to maybe different ways of doing this. Some people are interested in sort of outputting Terraform code from a sort of EKS Control dry run sort of scenario that they can then port into Terraform. There are other cases, thinking about maybe there being a Terraform provider that sort of drop down into EKS Control and then use that to create. So there are a number of ideas in this space, and we see lots of our users and also our clients, our customers on the commercial side, using Terraform and using a combination of Terraform and other tools. And I guess for me, that is a sort of a Q1 2020 objective, is to kind of make things, make Terraform and the EKS Control kind of work better together for some value of better. So if you have ideas, raise issues there. I am looking and sort of using that as input. If there are issues that are already open, like drop a use case on there, drop a scenario that you're working in. I often contact people in the chat if they're talking about this kind of topic, and sort of get some one-to-one sort of idea, digging into what people are doing. And I think that is an area that we would really like to get some more work done in. So planned in the sense of, are the team ready to do some stuff on it? No, but it's definitely a high priority item.
Brilliant. That's all we have time for, unfortunately. There are a few more questions. You have included your name, so we'll be sure to email you those answers after the webinar.
All right. Thanks a lot.
Great. Thanks, everyone.
Cheers.